everyone.
Hi, this is Ray and Malcolm, and Malcolm's actually going to run the slideshow, but I'll talk for this part. I'm the director of F5 Labs, and Malcolm is a researcher with F5 Labs. We've both been with F5 for a long time. Malcolm, many years, as you've heard. F5 Labs is actually the threat research wing of F5, so we got a bunch of cool data to share with you today. So let's just get on with it. Should go to the next slide, please. So we have a partnership with Effluxio, who's run by many different names, Lorica, Baffin Bay, now they're called Effluxio, but it's essentially the same folks that we've been working with since 2017. And they have a global honeypot network. And we collect a lot of data from them and various things. And one of the things that we really single our attention on is their web sensors, their web attacks. So we actually have, it says variable number of sensors. It's easily to say in the hundreds all over the world. And we see, as you see, 11,000 events per day on average. And that's just the web attacks. And we actually are able to capture a bunch of data. What these honeypots do is they actually simulate a web server in the most basic sense. They see an incoming connection and they kind of answer like, yeah, I speak port 80. Here's my HTTP. And then we grab that session and then they shovel all that data to us. And so we've been doing various stories and analysis on upcoming attack trends and things like that and kind of interesting events. And we'll get into that as we go along. But we also decided we were, for the special 20th anniversary, we wanted to do like a big picture. Let's look at all the data we had. So we have 8.5 million events, and Malcolm crunched through it and found some really interesting things. And we're also going to talk a little bit about the process that we did, because I think that's also interesting and useful to you, especially if you want to be doing some of this stuff on your own as well. Go ahead to the next one, which I think.
I think that's where I take over. Yeah. So I can talk a little bit about some of the tooling that was used for the analysis. We use a pretty standard set of data analysis tools, Python, including libraries like Pandas and NumPy, Jupyter Notebooks, some R, and most recently Elasticsearch. And Elasticsearch has been really extremely helpful when I approached this project to not just do an analysis of a relatively limited time period, like say a month or a quarter, but instead tried to look at this entire data set that covered years. That gave us the scaling that we needed. Originally, the data was in comma separated values, and now it's in JSON. There's pros and cons to both. Some tools work better with some and others with others. It's been relatively easy to transform the data between the two as we needed to. But if you were designing a system like this yourself, I would probably recommend that you consider JSON as being the more flexible format for it. We've managed to come up with automated ingestion. It's approaching real time. We're at about a day now, about a day lag. We're hoping to be able to get it down to hourly or even just direct pipelining into our analysis infrastructure so that we can start doing some really good automated analysis on it. We've obviously done a fair amount of trends over time, looking at different attack patterns, but what we would like to do is to use this as a source to be able to profile the attack patterns, for example, URLs that we're seeing, GET request URLs that we're seeing, and start to, probably using some sort of machine learning, classify them automatically and detect anomalies as we go forward so that we can see new attack patterns coming forth. That will also, using some of the other fields that we have, allow us to do some attacker profiling. Where are they coming from? What time are they coming in from? What ASN are they coming in from? That sort of thing. And we also have geolocation data, which would allow us to do more regional reports, both on where scans are coming from and where they're heading to. Some of the challenges that we faced is essentially that over time, when you're looking at a data set this large, we were looking at different pieces of data earlier than we are later. We've added the things that we are capturing. We've changed around some of the ways that we capture that data. So there was a fair amount of data cleaning and coalescing that needed to be done. Obviously, also, as Ray mentioned, we have a couple of hundred sensors minimum, but that number has actually gone up significantly. And the more sensors we have, the harder it is to ingest the data that we're getting. The web data set is, as these things go, relatively small, but we also have some other data sets that are probably an order of magnitude or two larger. And that starts getting a little bit difficult to do without some pretty serious infrastructure behind it. It's just quite a lot of data. Right now, the classification of the web attacks that we're seeing in terms of like, what does this request represent in terms of an attack is a mainly manual process. And we're hoping, as I said, to automate that, but that was a bit of a chore to go through even the relatively limited set that we had here and come up with some sort of reasonable classification scheme. And there are, of course, costs associated with maintaining the sensors, storing all the data in a way that you can get to it easily and do your analysis, and also just preserving it over the long term. I think an awful lot of companies have much of the same sort of data from, say, their web application firewall or their logs even, but they don't necessarily keep 5, 10 years worth of it to be able to do the sort of trending that we're going to do. So we started off by classifying the attacks. And in order to be able to talk about this, I think I need to define a little bit more about what the sensors can do and what they don't do. None of these sensors have DNS host names. They're not pretending to be a specific company or a specific vertical or, you know, Bob's Happy Fun website or whatever it happens to be. There's no particular thing. They're really just an IP address hanging out on the internet, waiting for traffic to arrive to them. They additionally don't pretend to be a specific platform. They're not pretending to be an Apache with PHP or an Nginx or something that has, you know, JavaScript on it or anything else like that. They're really just a listener listening on port 80 and port 443, able to receive an HTTP or a TLS connection, negotiate it properly, and record the request that comes in. That's literally it. So what does this give us in terms of the visibility into what's happening on the internet and the web? It gives us the ability to see scans that are widely and non-specifically targeted. These are scans that are probably going and traversing a large section of the IP space. They are not targeted to specific companies. They're not targeted to specific domains. They are really just going and perhaps scanning, you know, a class A at a time or something like that. That probably dates me a little bit, but a large number of IP addresses at a time. And so it's reasonable to conclude that the attacks are automated and are done at scale and are probably done, therefore, by attackers who are looking for easy wins. They're not necessarily targeting a specific industry or site. They are just trying to find things that they can break into or install software on, which we'll get to in a little bit, or retrieve information from. Attack classification is the next thing really that we looked at. And as I said, what we've generally seen, and I think this is actually probably true for a large amount of attacks on the internet, is that attackers are going to target technologies and not necessarily industries. They are picking up public vulnerabilities quickly. Those get weaponized, automated, and start being used. And they continue being used for a very long time, as we'll see. The most apparent goals that we've been able to determine from what we've seen, and this is mainly from command injection payloads, is they are interested in installing crypto miners or building botnets. And probably the most common botnet that we've seen, general classification of botnet, I should say, is for doing denial of service attacks, such as the XOR DDoS. Many of these attacks can be automated completely. You see a GET request comes in that uses a command injection, that issues a curl command that downloads something from some server somewhere, untars it somewhere, and starts running it. And you can do that all on one GET request. Secondarily, we see a lot of attempts at going and looking for files that would reveal credentials. .env, for example, where unfortunately you find a lot of database credentials or general configuration files that may include passwords or key data. And so from this, we conclude that at least this particular subset of attackers are going to be using the shortest path to their goal. And their goal is widespread compromise and information theft. So they're not going to be particularly picky about what tools or technologies they use. So now we can talk a little bit about what sort of attacks you might be expecting. And we can say generally that any HTTP or TLS endpoint will be scanned probably within less than 1 hour of it being visible. And your authentication endpoints will be cred stuffed and brute forced. If it's got a login box on it that can be exercised by a remote attacker, it's going to be exercised by a remote attacker. Any data that's in the open is going to be found and taken. Specifically, PHP will be enumerated for command injection vulnerabilities. We see a ton of requests for common test script names, for example, test.php or shell.php or aaa.php or temp.php, any of these sorts of things, which I assume is attackers looking for people coming up with a quick little test script, leaving it out in the open, and perhaps being able to find something that they can exercise to do a command injection, most likely. Interestingly, APIs, specific API URLs, in other words, ones that comply to a format that indicates an API endpoint, /API would be the most common one, obviously, but there's many other patterns that we see are being actively scanned for. They're going to be found, and they are going to get poked at quite sufficiently. And finally, any public web vulnerability, any CVE that comes out that anybody has any idea about how to actually use are going to be picked up quickly, turned into an automated tool, and you're going to see those all the time. I'm just going to pause briefly. Okay, thank you for the time warning. So, in order to take a look at this data over this large chunk of time, we use the following approach. We looked for the top 50 requested URIs per month, 2017 to 21 inclusive, until just a little while ago in mid-August. Actually, yeah, a little while ago in mid-August. We normalized it for the number of sensors so that we had comparable data sets. And we did some manual classification. We broke it out this way. We came up with APIs, specifically the enumeration and attempted execution of APIs. Authentication, which is requests for login pages or specific login attempts, post requests with credential data in them. We looked for code and content inclusion, which I'm defining here as cross-site scripting, local file inclusion, remote file inclusion, and several other techniques. Information theft and recon, which is, as I mentioned, looking for example, .env files or .password files or .htaccess files, those sorts of things. Injection and remote command execution, specifically command injection most often, but also specific remote code execution vulnerabilities. And then finally, SQL injection, which we separated out from injection more generally, because we saw in the data a really interesting pattern emerge. So here's what we saw. Over, obviously, on the left, we have 2017, all the way to the right, 2021. The green color on your screen is what we observed for SQL injection attacks. And as you can see, they were by far the majority of the attacks that we saw from when our data set started in 2017 until about July of 2018. And they were ubiquitous. There was just so many of them. Code and content inclusion did have a representation in there, as well as authentication, some of the other categories here. Then we saw a really big shift. There was a sudden spike in injection RCE classified attacks, and I think we're going to figure out exactly what those were here in a couple of slides. But after that point, you'll notice over on the right side of the graph, especially with the orange, which is off, and the blue, which is API, a significant and ever increasing trend for scans that were targeting those two classifications. I think this is really, really interesting. What we may be seeing here, and this is speculation, but what we may be seeing here is a shift from using traditional SQL-backed web architectures to perhaps ones using NoSQL, or perhaps just people fixing SQL vulnerabilities, which made those attacks less likely to succeed. And at the same time, we see an increasing amount of API usage, and also attackers just pivoting to what they can reasonably conclude that they can get in with. In other words, API, cred stuffing, password spraying, all those sorts of techniques. The info theft and recon category has been growing as well. And the injection RCE has continued to be something that we've seen a lot of. But I really want to call out that specific trend of increases in auth and API traffic, because I really think that that's actually where that's a major shift that we're seeing. It may be that some older techniques that attackers were using are less effective, but they are definitely keeping up with the shifts in web architecture that we're seeing, where APIs and microservices and that sort of thing are becoming more common, and they are definitely arising into the targeting that attackers are doing here. So we found a couple of, just to call out a couple of different things that we found that were kind of interesting. CVE 2017-9841, my apologies, was actually found in 2017. It emerged strongly in 2019. We caught it about halfway through September in 2019. It's been continuous in our data set since October 2020. Now, it peaked somewhere in there, but it still continues to this day. And it's still quite significant, which I think is interesting, because one would assume that such an old CVE would perhaps fall out of the data set that attackers are using, but it's not happening. They continue to use it. Now, whether this is because it's easier just to leave it in, or whether it's actually still being effective, I don't actually know. My suspicion is probably more the latter. Generally speaking, attackers are pretty good about optimizing what they're doing for efficiency. And when you're scanning large chunks of the internet, that becomes an important thing. So I'm expecting that this particular CVE is probably something that they're still finding some instances of. CVE 2019-11510 does actually tell a slightly different story, which is this was a vulnerability in the Pulse Secure SSL VPN. It was a critical, the CVSS score of 10. We saw it first at the very beginning of August. It had a huge spike right after that in mid-August. Scans continue to this day, but at a much lower level. And just to correlate that a tiny bit, that might actually be corresponding to that August. Some of these actually. Oh, no, I'm sorry. I'm getting this a little bit confused. Some of this definitely accounts for the spikes that you see, actually that first blue spike there, especially the 2019-11510 was definitely present within that 2-month span where you see the first big light blue spike. Now with that, I'm going to hand it over to Ray to talk about a few other interesting things that we've found.
Thank you. I'm going to kind of go through these a little quicker because we're kind of running out of time here. But you also can see the links in the bottom of the site here, or the video, so you can actually go to the site and see the longer versions of these little stories. One of the things we did when we first started analyzing this data is we saw this huge spike of PHP attacks. Now we see a lot of PHP, but actually starting to, one of our other researchers, Sander Vinberg, who works on the App Protect report, found was these are actually coming just from two servers, two particular servers at a North American university, and just targeting a couple of CVEs. But these things were pretty much swamping our data to the point where we actually had to take them out of our data set and separate them just so that we could see everything else because they were pushing everything back down. But it kind of goes to show that, like, there are boxes out there that just go crazy and they just run crazy for months. We did try to contact the owners. That can just, spray across the internet constantly as a loud horn. Go on to the next slide, please. I was going to say these are some, yeah. So another thing that we saw, another big spike in scanning, and we also look at these things globally, and this is combined both web traffic and some non-web traffic. So it was kind of funny. The analyst came to us and said, "Hey, there's this huge spike of scans against Singapore coming from Russia in this week. What's going on?" I said, "President Trump is in Russia right now, meeting with the president of North Korea." And I was like, "Oh wow, well, these are all SIP scans and IoT scans. So, are we looking at some sort of interesting espionage action?" It's like, who knows? And who knows if it's actually Russia? I mean, you never know when you're looking at an IP address. Go on to the next slide. I was going to say, we started following this data, and next thing we know, we saw the same thing in Finland, except for now the scans were coming from China, and he was meeting with Vladimir Putin. So, you can see some kind of interesting, weird stuff in the data. Go on to the next one, please. And lastly, we were looking through the data and just noticed there was a coffee pot. The coffee pot was hitting our network, just scanning away. And some of the people kind of went, "Oh my God, it's a coffee pot bot. It's the end of the world." I was like, "Oh, maybe somebody just misconfigured something," or I don't know. It was beaconing, but it was. If anybody's got any theories as to what this was about, I'd love to hear it, because it was pretty bizarre. And we have not seen it since, because we're definitely been looking for it. Go ahead to the next one, Malcolm, and take over, please.
Okay. So if you want to do something like this yourself, it's probable that you can. In my experience, weblogs and WAF logs can be treasure troves if, especially, you maybe do some pre-analysis and store perhaps even just some counts of what you see for the long term, and then continue that over time. You're going to get some interesting trending data. You can use a similar approach with your network edge. You can sample. It doesn't necessarily have to capture absolutely everything, because I know that can be challenging, especially with the sort of amount of data that we have flowing in and out of our networks. But even some random sampling can yield some interesting results. And it's actually really interesting to see what's hitting you, even if it's getting blocked, or even if it never reaches anything in your infrastructure because it's stopped at the firewall. I think that actually, while you don't want to spend obviously tons of time analyzing it and tons of space storing it, occasionally checking in on it or gathering some summary data is actually pretty useful to kind of figure out what sorts of things attackers are trying. And when you see a shift in their behavior, it can give you a little bit of a distant early warning. Like, maybe you're not using APIs yet. Maybe your company's not quite there yet, or is trying to figure out if that should be your strategy. Well, maybe you could make the case that you need to invest in some API security before you roll that out, given the fact that you might be seeing a lot of API traffic getting something, even though you don't actually have it yet. The big picture takeaways here: attacks against API and author rising. Those are the two things that I would recommend anybody really be looking at. Does your authentication endpoints have adequate protections in terms of protection against brute force, credential stuffing, obviously good passwords, password reuse, all of the sorts of things that you need to do to protect your auth infrastructure. And I know for a fact that the OWASP website has a huge amount of data about many of these techniques, so I would refer you there. SQL injection is falling off. Certainly, it's still an issue if you use SQL to back your apps, but it does seem to be falling off. But command injection remains very popular. So basic app security stuff to protect yourself against command injection is absolutely there. One interesting question that I had was, since the OWASP top 10 combines SQL injection and command injection into one category, is the fall off in SQL injection and a steady state in command injection the reason why injection has fallen a position or two within the OWASP top 10 that was just recently released? I think it might be, but I'd be interested to hear if anybody has any data on that. Info disclosure is on the rise. People are looking for places where people store passwords or leave authentication keys around, whether that's .env or .git files or anything like that. So having some hygiene around how you store things is extremely important. And then public vulnerabilities. Of course, attackers pick these up as quickly as they can, which is often very fast, within a week or two. And they use them heavily for about 3 months. And then they don't go away. They last for sometimes years within the tool sets of the attackers. So with that, we're done. Thank you very much for your time. And if you want to get in touch with us, you can find us on Twitter, LinkedIn. We have a great email newsletter as well. Ray, do you want to say anything else?
Come to f5labs.com. It's just all material. You can download it. There's no advertising or anything. It's for the security community. Thank you.
Absolutely. Thanks very much.